Hello students, the accelerator theory assumes that current capital stock is a function of the previous or current year's output, and one of the defects of this acceleration theory is that it assumes instantaneous adjustment. That is, if current output is expected to increase by a certain amount, then the capital stock also adjusts in the current period of time. This discrepancy was found by later economists when they did an empirical analysis. They found that the value of accelerator coefficient nu was considerably less than the hypothesis by the simple acceleration hypothesis, and therefore they arrived at the conclusion that actually the capital stock was a lag function of previous levels of output, and therefore they model current year's capital stock KT as a function of not only current level of output YT but also of previous output YT minus 1, YT minus 2 up to YT minus n. So current year's capital stock is modeled as a function of previous year's output levels, and this theory is known as flexible acceleration theory because it was different from the simple accelerator model in that it ruled out instantaneous adjustment in the capital stock. And the flexible acceleration theory uses chaos transformation approach to solve for the net investment, and therefore this also known as chaos transformation approach. And this approach, in this approach, chaos gave decline geometric weights to each year's output, with current year output getting maximum weightage and the most distant past year output getting the least weightage. The weightage attached was lambda, and therefore the capital stock function can be modeled as KT is equal to nu into 1 minus lambda into lambda YT comma lambda YT minus 1 plus lambda square YT minus 1 plus lambda cube YT minus 2 up to lambda raised to n YT minus n minus 1. Okay, so this is the way that flexible acceleration theories model the current capital stock. Now they assume that the income level is constant throughout the period, and so output is also constant, and therefore YT minus 1, YT minus 2 and YT minus n minus 1 can be assumed to be equal to y bar, and therefore the equation changes form into nu into 1 minus lambda into lambda y bar plus lambda square y bar plus lambda cube y bar plus dash up to lambda raised to n y bar. Okay, now we are taking out this common term y bar from the equation, and now so we get nu y bar into 1 minus lambda into lambda plus lambda square plus lambda cube plus lambda raised to n. Okay, and this is a geometric progression, and therefore the sum of this geometric progression has been defined as 1 by 1 minus lambda. Therefore this term can be replaced by the term 1 by 1 minus lambda. So the equation again changes form to nu into y bar into 1 minus lambda into 1 by 1 minus lambda. Okay, 1 minus lambda into 1 by 1 minus lambda is equal to 1. This term is equal to 1, and therefore current year's capital stock becomes nu into y bar. Okay, so KT, what we are arrived at is that KT is equal to nu into y bar. If KT can be written in this form, KT minus 1 can also be written in a similar way. Why KT minus 1 is important? KT minus 1 is important because in order to find net investment, we have to subtract KT minus 1 from KT. So we are actually finding the amount of net investment. Okay, how net investment comes. So we we write the equation for KT minus 1 or previous year's capital stock. KT minus 1 is equal to nu into 1 minus lambda into lambda yt minus 1. Here this yt changes to yt minus 1 because here we have been modeling the current year's capital stock, but here we are modeling previous year's capital stock. So lambda yt becomes lambda yt minus 1 plus lambda square lambda yt minus 1 lambda square yt minus 2 plus dash 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 up to lambda raised to n yt minus n lambda raised to n yt minus n yt minus 1. So this is previous year's capital stock kt minus 1 kt minus 1. Now we are multiplying this term previous year's capital stock with the lambda, and the equation again changes form to nu into 1 minus lambda into lambda square yt minus 1 plus lambda cube yt minus 2 plus dash 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 up to lambda raised to n plus 1 into yt minus n into yt minus n. Okay, so this is the new term for kt minus 1. Now we have to find the net investment, which is nothing but the difference between kt and kt minus 1. So lambda kt minus 1. Here kt minus 1 becomes lambda kt minus 1 because we are multiplying both sides of the equation by lambda. So we are subtracting lambda kt minus 1 from kt. So kt minus lambda kt minus 1 equal to, here we are cancelling out the terms. We are cancelling out all these terms, and what remains will be yt plus lambda raised to n plus 1 yt minus n. Okay, so this is the remaining term equation. So what remains in the equation is nu into 1 minus lambda into yt plus lambda raised to n plus 1 yt minus n. So this is what remains in the equation when we are subtracting lambda kt minus 1 from kt. We are subtracting lambda kt minus 1 from kt, and we get nu into 1 minus lambda into yt plus lambda raised to n plus 1 into yt minus 1. We know that the value of lambda raised to n plus 1 approaches 0 as n approaches infinity. When n is infinity, the value of lambda raised to n plus 1 will be 0. So this term becomes 0, and the equation again becomes nu into 1 minus lambda into yt. Nu into 1 minus lambda into yt. So net investment is given by kt minus lambda kt minus 1 equal to nu into 1 minus lambda into yt. Now this lambda, if we bring the lambda kt minus 1 to the right side, then this equation becomes kt is equal to nu into 1 minus lambda into yt plus lambda kt minus 1 lambda kt minus 1. Okay, so this process of writing the current year's capital stock is known as pure transformation approach. Here current capital stock has been defined as nu into 1 minus lambda into yt plus lambda into kt minus 1. Okay, here now we have to find the net investment. Net investment is the difference between current year's capital stock and previous year's capital stock, which is kt minus 1. So in order to find the net investment, we have to subtract kt minus 1 from kt. So we subtract kt minus 1 from this equation in order to get the net investment. Net investment is equal to nu into yt into 1 minus lambda plus lambda kt minus 1 minus kt minus 1. This terms is KT, this is KT minus 1. So subtracting KT minus 1 from this, we get net investment. And this can be written as mu into YT into 1 minus lambda plus lambda minus 1 into KT minus 1. This is the equation for net investment. Here, net investment is hypothesized to vary positively with the level of output. Higher the level of output, greater will be the net investment, and negatively to vary with the existing capital stock, because higher the existing capital stock, higher will be the excess capacity, and therefore less likelihood of an increase in investment. So output affect capital stock positively, and level of capital stock, level of existing capital stock affect the investment negatively. Now gross investment is equal to INT plus depreciation. INT plus depreciation. INT is mu into YT into 1 minus lambda plus lambda minus 1 into KT minus 1. Plus depreciation, we give delta as the coefficient for depreciation. So depreciation can be written as delta KT minus 1. Delta KT minus 1. So this equation again can be changed into mu into YT into 1 minus lambda plus lambda minus 1 plus delta into KT minus 1. Here this is the term for gross investment, and it shows that this is for net investment. This is the term for net investment, this is the term for gross investment. This equation shows that gross investment varies positively with the level of output. Higher the level of output, higher will be the gross investment. And here capital stock has a dual role. Firstly, it affects gross investment negatively, because higher the capital stock, higher will be the excess capacity, and less will be the chances of an increase in investment. Whereas a higher capital stock also means that more gross investment, because higher the capital stock, higher will be the depreciation, and therefore higher will be the replacement investment. And this is the flexible accelerator model. This is also known as a distributed lag model, because the capital stock is assumed to be a distributed function of previous levels of output. So this is also known as distributed lag model of investment. Okay, thank you.